we will learn how to actually calculate a cross product, and we'll do some examples. Okay, so the first thing is, it takes a bit of work, but we can show that the cross product is what's called linear. In fact, bilinear is what you really need. Now it does stand to reason that this is true. So this will be, you can think about this as the moment of a sum of forces is equal to the sum of the moments. Which stands to reason. And what that means is, if you've got two coordinate form vectors, you can multiply them out. So what you get, say for example, if we have, say, we'll do it with a natural example, I minus 2j plus, say, 3k cross product 2i minus j plus k. Now I'll just start multiplying this out. So the I cross product with the I, now things that are parallel have a 0 cross product. So I cross 2i is 0. Now look at I cross minus j. Now we had it up there. I cross j is actually equal to k. So when we do the I cross the minus j, we get minus k. Then with the I cross k, you can show is minus j. Now we got minus 2j cross 2i, so the minus 2 by the 2 gives you minus 4. And you can show that j cross I is minus k. So we have minus 4 by minus k plus 4k. Now the 2j crossed with the j, those vectors are parallel, or even if they're anti-parallel as well, the vector product will be 0, so they disappear. So the like terms are equal. Let's just say 0. And then we do minus 2j by k. So j cross product k is actually I, so you get minus 2i. And then I think we're going to finish this off. 3k cross 2i, k cross I is j, and if 3 by 2 is 6, we get a 6j. This actually isn't the worst way of doing it, to be honest. We won't do it this way, but it's not the worst way of doing it. 3k cross minus j. Now k cross j. Now you have to multiply in the right order, of course. You can't do j by 3k. It has to be 3k by j. And k cross j is minus I. So you get 3 by minus 1 is minus 3. By minus I is plus 3i. Now that should be a bit confusing, but that's not actually how we're going to do it, because it's kind of hard to remember. But that's the basic idea. And it turns out that you get this kind of a formula down here, which is a nasty kind of a yoke as well. I'm going to show you a nice way to remember this that is useful for you in the second chapter as well. Okay, so there's an easy way to remember this formula. So what you do is you write, so suppose, let me just look at the ones we were doing there. So it was 1 minus 2, I'll just pause there and write these down. I suppose we should probably tidy this up as well, just so we can check that we get the same thing. So we gather all our i's, minus 2i plus 3i. Hopefully this works now. If it's wrong, I'll have to come back and fix it. Minus j plus 6j is 5j. And we've got minus k plus 4k, which is 3k. So that's our answer that we're looking for, 153. Okay, so I have these vectors written down beside me, and I'm going to show you how I'll actually calculate these in practice. So you were looking for the cross product of, it was 1 minus 2, 3. And remember, the order is important. If you change the order, you get minus the answer. Cross product 2 minus 1, 1 equal to. So you write ijk along the top. You write the components of the first vector in the second row. So that's 1 minus 2, 3. And then of the third one down below, 2 minus 1, 1. Now it is possible to make this makes sense, but to be honest, it's just a way for us really to remember the formula. So what you do then is so this is actually an object. It doesn't look like something at the moment, but it is. This is a determinant we'll learn about more in the next chapter, and I'll just show you a way of calculating this thing. So I'm going to write down the same array again. Array, or this will be called a matrix. So what you do, the first thing you do is you write down the first two columns again. So that's I1, 2, J minus 2 minus 1. Then what you do is you multiply across the right down diagonals and add them up. So I'll show you what I mean. So you do I by minus 2 by 1. That's one of the right down diagonals, plus J by 3 by 2 plus K by 1 by minus 1. That's the right down diagonals. We'll do that here. So I by minus 2 by 1 is minus 2I. J by 3 by 2 is 6J. And finally, K by 1 by minus 1 is minus K. So that's your right down diagonals. Now, how about your left down diagonals? So your left down, and they have to be these full diagonals. Now you multiply along the diagonals. J multiplied by 1 multiplied by 1. I multiplied by 3 multiplied by minus 1. K multiplied by minus 2. And be careful with the signs, multiplied by 2. Take away the left, they're going to left, they're down, and they are diagonals. So J by 1 by 1 gives me J. I by 3 by minus 1 gives me minus 3I. K by minus 2 by 2 is minus 4K. And then this is equal to, gather the i's together, minus 2I minus 3I is minus 2I plus 3I, which is I. 6J minus J is 5J. And minus K minus 4K is minus K plus 4K, which is 3K. So we're looking at the vector 1, 5, 3, and we'll just check, did we get the same thing? 1, 5, 3. Yeah, happy days. So this is how I recommend that you calculate these cross products. It's a bit bonkers, I appreciate, but it does give you the right answer. There's theoretical reasons why this works as well, but I'm not actually so hot on that particular thing. So what I recommend now is that you pause the video. So this is your effort. Pause the video and do this question yourself, and then unpause and drive on. Okay, so if you pause, that's great. Otherwise, do it now. Okay, we're back. So let's do U cross V. So U cross V equal to, it's a determinant I, J, K. Put the components of U first in the second row. 1, 3, 4, and then the components of V, 2, 7, minus 5. Okay, then what you do is you write the first two columns again. So that's I, 1, 2, J, 3, 7. And now you do right down diagonals minus left down diagonals. So that's I by 3 by minus 5, J by 4 by 2, K by 1 by 7. So this is I by 3 by minus 5. So minus 5 by 3 is minus 15, by I is minus 15I. 4 by 2 is 8, by J gives you 8J. And 1 by 7 is 7, by K gives you 7K. Okay, take away the left-hand diagonals. J by 1 by minus 5, I by 4 by 7, K by 3 by 2. So that was J by 1 by minus 5 is minus 5J. I by 4 by 7 is 28I. And 3 by 2 by K is 6K. And then you just do those right down diagonals minus left down diagonals, see what we get. So minus 15I minus 28i is minus 43i. 8j minus 5j is 8j plus 5j is 13j. And finally 7k minus 6k is 1k. And if you haven't got that right, you can hopefully see where you went wrong, or if you want, you can always email me a question. Okay, so I've got a thing here, the image of the toilet roll holder is one that helps me with examples like this. So the toilet roll is back on page 8. We'll just have a look at that there. This thing. So if you have two vectors and you want something perpendicular to both of them, you take the cross product. Now I can't remember what page I was on. Not far off. Okay, let's see. Find a vector perpendicular to the plane that passes through these points. So if you've got some points in space, say P, Q, R, imagine putting an infinite sheet on them, and in that sense they all lie on a plane, as long as the 3 points don't fall on a line. So wherever it is, you can put a sheet on them. So imagine just these 3 little ball bearings in space. Wherever they are, you can put an infinite sheet on them. Okay, so let's say this is P, Q. I'm actually going to change it just to make more sense with the right hand rule. Q, or it doesn't really matter. So find a vector perpendicular to the plane that passes through the points. So if you want something perpendicular to this, what you can do is you can look at the vector, say P to Q, which is a vector in this plane. You can imagine it now, you kind of put the plane on the ground, on the floor, and you have another vector going from P to R. So you got vector P to Q, P to R. And if you want something that is perpendicular to this plane, you can do the vector product, the cross product. Now, if I do PQ cross PR by the right hand rule, I get this thing. So this is PQ cross PR. But if I want to do it the other way, it doesn't matter. I just get, say if I did PR cross PQ, it'll just be the same thing but negative. Right, so you've got 2 vectors in a plane. Take the cross product of them, you'll get something that's perpendicular to both. So the vector PQ cross PR is perpendicular to both PQ and PR and is therefore perpendicular to the plane. We know how to calculate P to Q and P to R. We just do Q minus P, etc. And let me get this on another screen for myself. So P, the vector from P to Q, is Q minus P. Q is minus 2, 5, minus 1. Take away P is 1, 4, 6. So I get minus 2, remember you just take away component wise. Minus 2 minus 1 is minus 3. 5 minus 4 is 1. And minus 1 minus 6 is minus 7. Yeah. And then we also want to do P to R, which is R minus P. And obviously you can do different combinations. I mean, you can do R to Q and R to P, or you can even do P to R, and you can do any combination. So I think you just have to take, there's like how many vectors there? There's actually 6, any 2 of them that aren't kind of the same thing. So they can't do PR and RP obviously, but anything else will do. So the point R is 1, minus 1, 1. Take away P is 1, 4, 6. That gives me 1 minus 1 is 0. Minus 1 minus 4 is minus 5. And 1 minus 6 is minus 5 as well, isn't it? Okay. And now we want to do the vector product of these two to get something that's perpendicular to the plane. So our answer will be like PQ, is it PQ we're running with? Yeah. PQ cross PR. So we do I, J, K. The components of PQ, which are minus 3, 1, minus 7. the components of PR, which are 0, minus 5, minus 5. We remember the whole time you can pause me in these videos. Turn me off as well. Write the first two columns, I, minus 3, 0, then J, 1, minus 5. And what we're going to do is we're going to do the right down diagonals minus the left down diagonals, as we've seen before. So I by 1 by minus 5, J by minus 7 by 0. Now remember again, be careful multiplying by 0. It's not multiplying by nothing. It's multiplying by 0, which isn't the same thing. If you multiply by nothing, nothing happens. If you multiply by 0, you get 0. And K by minus 3 by minus 5. So they're the right down diagonals. So I by 1 by minus 5 gives me minus 5i. J by minus 7 by 0 gives me 0. 0j, same difference. It's not the number 0, it's the vector 0. K by minus 3 by minus 5 is minus by minus is plus 15k. That's your right down diagonals. Now what about the left down diagonals? J by minus 3 by minus 5, I by minus 7 by minus 5, K by 1 by 0. So minus J by, J by minus 3 by minus 15, minus 3 by minus 5. Sorry, I said some nonsense there. J by minus 3 by minus 5. The minus 3 by the minus 5 gives me 15 by J. There we go. Minus 7 by minus 5 there is plus 35 by I. And then K by 1 by 0 is the 0 vector. You're okay if you just write 0, to be honest, but it is different. Right, so minus 5i minus 35i. I'm going to check the answer to this. I'm a little bit dubious. It's minus 40i. There's no j's here. So it's just minus 15j. And then it's just plus 15k. Now, actually, here's a great thing we can do to check our answer. So suppose you calculated a vector product and you want to check your answer, and just see is it up there? It's not. No. So one thing you could do, now of course we can just check our answers here. I've taught this module so many times, it doesn't look familiar to me. So P to Q is Q minus P. If I've taken down that right, 1, 4, 6. That's minus 3, 1, minus 7. That's correct. And then P to R. Yeah, 1 minus 1 is 0. Yeah, it's right. But what we can do, like if these were right, so these vectors here should be perpendicular to this thing. So if I do the dot product of these with this, I should get 0. And that shows that this is perpendicular to them. So let's do little dot products there. So minus 3, 1, minus 7, dot product with minus 40, minus 15, 15, we have to get 0 or something's gone wrong. Okay, so minus 3 by minus 40 is 120. Remember, this will be a number, and it'll be 0 if they're perpendicular. Plus 1 by minus 15 is minus 15. Plus minus 7 by 15 is minus 105, and that is equal to 0. And I think it isn't too hard to show, because they're both minus 5. You get 0 by minus 40, you get minus 5 by minus 15 is plus 75, and the other one is minus 75. You get a 0 dot product between PR and this cross product as well. So this, I'm quite happy with this actually. Okay, more examples. Okay, one more example for us here. So we've got vectors A, B, and C, and we're going to calculate two numbers, x1 and x2, and a vector, and we're going to investigate whether these are equal. Now this seems like a mad joke. This is called, I think if we write it all out, do we get something somehow interesting? We do. So this is called, I think, the back cab or something. So if you write what this is out, you get A cross V is B cross C. Now you do actually have to put in the brackets here, because if I do A cross B first, it's different. So now I've got a scalar by a vector. A number, the order of multiplication doesn't matter. So I put B there, and x1 is A dot C. Take away, and now again I've got a number and a vector. I can do it the other way around. So number and then x2, sorry, vector, and then the number is x2 is AB. Dot product. So this is called back cab rule. Okay, it's important in I think it's electronics or something. It's not that it's for you, it's just an exercise here. Okay, so off we go. Let's calculate first of all the two scalars, x1. So x1 is a scalar, so I don't put any arrow on it, it's just a number. A dot c. I'm just going to use the components rather than writing out all the ijk's. So a is 3 along the x. Now careful, minus j means it's minus 1 along the y and 2 along the z. Dot product, c is 2 along the x, 2 along the y, minus 1 along the z. So I get 3 by 2 is 6. Remember this is how dot product works, just multiply the components together and add them. It's a number. Plus minus 1 by 2 is minus 2, plus 2 by minus 1 is minus 2, 6 minus 4 is 2. Now we'll calculate the other scalar, x2, which is a dot b. So a is still 3 minus 1, 2, and b is the vector 0 along the x, because there's no I there. Now it's not a 0j, 0j would be 0, it's 1j, which means 1 along the y and 1 along the z. So I get 3 by 0 is 0, plus minus 1 by 1 is minus 1, plus 2 by 1 is 2. So look what I'm multiplying. 3 by 0, minus 1 by 1, 2 by 1, adding them together. So this gives us 1, good. And now what we have to do is, what are we going to do? Oh, I'm going to calculate v next. So that's b cross c. So the vector v is b cross c. And how we do a cross product, we put them in this determinant, ijk. If b is first, the order is important, b goes in row 2. If you mix up the order, you won't get b cross c, you'll get c cross b, which is, you'll get minus b cross c, you get the wrong thing. The components of b are 3, I'm just taking them from here, 3 minus 1, 2. And the components of c, that's wrong, isn't it? Sorry, the components of b is 0, 1, 1. And the components of c are 2, 2 minus 1. And what am I saying here? Write the first two columns again. I, 0, 2, j, 1, 2. And we're going to do right down diagonals. I by 1 by minus 1. J by 1 by 2, k by 0 by 2. So that is I by 1 by minus 1 is, you can multiply the numbers together first, minus 1 by I, which is minus I. 1 by 2 is 2, by j is plus 2j. And 0 by 2 is 0, by k is 0, so you don't have to put that in. That's the right down diagonals. Take away the left down diagonals, j by 0 by minus 1, I by 1 by 2, k by 1 by 2. So j by 0 by minus 1 is nothing. I won't bother writing it in. I by 1 by 2 is 2i. And k by 1 by 2 is 2k. Remember, I'm putting these hats on to communicate that the ijk's are unit vectors, and that means they're length 1. So minus I minus 2i is minus 3i. And 2j, there's no j's here, so it's just plus 2j. There's no k's here, so it's minus 2k. Okay, so that's the vector v. Now what we have to do is, so I've calculated x1, x2, and v. We have to investigate these two. So what we're going to do is we'll calculate the left-hand side first, and then the right-hand side, and we will compare. Okay, so a cross v I have to do now. So a cross v, I, j, k. Let's get a. A is 3 minus 1, 2, and that's the first one. That goes first, 3 minus 1, 2. And v we just calculated is minus 3 along the x, 2 along the y, and minus 2 along the z. we write the first two columns again. So that's I 3 minus 3, j minus 1, 2. And then we do right down diagonals. I by minus 1 by minus 2, j by 2 by minus 3, k by 3 by 2. That's the right down diagonals. We'll do that here. So I by minus 1 by minus 2. We can multiply those numbers together first. Minus 1 by minus 2 is 2, by I is 2i. 2 by minus 3 is minus 6 by j. And 3 by 2 is 6 by k. And now we want to do the other one, the left down diagonals. J by 3 by minus 2, I by 2 by 2, k by minus 1 by minus 3. So 3 by minus 2 is minus 6 by j. 2 by 2 is 4 by I. And minus 1 by minus 3, 3k. And now we'll tidy that up. Getting there. So we get for A, cross product with V is equal to 2i minus 4i, that's minus 2i, minus 6j minus 6j, be careful, minus 6j plus 6j is 0j, so I can leave that out, and then 6k minus 3k is 3k. And now let's calculate x1, now we're comparing this. We're comparing this minus 2i plus 3k, which is A cross product V, with x1b minus x2c. So x1b, so x1 is equal to 2, b is 0, 1, 1, minus x2 we found to be 1, by c, which is the vector 2, 2, minus 1. So do we get the same thing? So carefully multiply in the scalars. So if you have a scalar by a vector, you multiply everything there. 2 by 0 is not 2. 2 by 0 is 0. 2 by 1 is 2. 2 by 1 again is 2. Take away. Now 1 by anything is the same thing. So you get 2, 2, minus 1. And now carefully, the x component 0 minus 2 is minus 2. 2 minus 2 is 0. And 2 minus minus 1 is 3. And look at that, minus 2 along the x, 0 along the y, 3 along the z, the same as minus 2i plus 0j plus 3k, which is exactly what we were supposed to show. Happy days. Okay, and don't mind that learning activity. So that's a lot of the vectors done. Now you have, I don't know how long those lectures were, but it isn't 3 hours. You've got plenty of time, even if you're just doing 3 hours, to work on exercises and submit to Canvas. So I highly recommend that you carry out the learning tasks in the Canvas.